Dr. Balaga here. I have another terrific God Knowledge Doc podcast for physicians and advanced practice providers, including physician assistants and nurse practitioners. You should find this podcast very useful in your practice. My disclosures are I have a podcast called God Knowledge Doc. Many of the podcasts are on cardio-oncology, and I'm one of the editors for the International Cardio-Oncology Society Board Review Manual. In this podcast, I will be discussing Cachexia. There were recent papers in JACC and in Nature which are relevant to this topic. The JACC paper, which came out in June of 2023, was for Marcus Anker's group, and he had several co-authors from different centers. It looked at body wasting in patients with cancer, how body wasting in patients with cancer can affect the heart. The objectives of the study was to determine the frequency, the extent, the clinical and prognostic importance of cardiac wasting in cancer patients. This was a prospective study which enrolled 300 patients with mostly advanced active cancer but without significant cardiovascular disease or infection. These patients were compared with 60 healthy control subjects and 60 patients with chronic HFrEF with an ejection fraction less than 40%. And they were of similar age and gender distribution. What did they find? They found that cancer patients presented with lower left ventricular mass compared to healthy control subjects, as assessed by transthoracic echocardiography. The cancer patient weight of the heart was around 177 grams, whereas it was around 203 in the healthy controls and 300 in the heart failure patients. The LV mass was lowest in cancer patients with cachexia. It was around 153 grams. Importantly, the presence of the low LV mass was independent of previous cardiotoxic chemotherapy. In 90 cancer patients with the second echocardiogram, after around 120 days, the LV mass declined by around 10%, 9%. In cancer patients with cardiac wasting, during follow-up, the stroke volume was decreased, and during follow-up of an average of 16 months, 149 patients died. The LV mass and the LV mass adjusted for height squared ratio were independent prognostic markers. So this was a very important study, which, in a nutshell, the LV mass in healthy controls was around 203 grams. In all cancer patients, were 177 grams. In cancer patients without cachexia, it was around 187 grams. And in patients with cancer cachexia, it was about 153 grams. Whereas in heart failure patients, it was around 300 grams. This is an important study. Ideas for further research include repeating the study with cardiac MRI, and more importantly, to correlate these changes with potential cDNA or microRNA and other biomarkers to better delineate the mechanism of the findings of this study. The next study I'm discussing today is from Nature, May 2023. It looks at ectrodysplasin A2 receptor and the NIK signaling, that is the NF-kappa beta inducing kinase signaling. These researchers have found that the ectrodysplasin A2 receptor NF-kappa B inducing kinase signaling promotes skeletal muscle atrophy linked to cancer cachexia. This study, using gene expression analysis in muscle tissues, indicated upregulation of ectrodysplasin A2 receptor in tumor-bearing mice and in patients with cachectic cancer. These investigators show that the activation of the ED2AR signaling promotes atrophy of skeletal muscles. Stimulation of primary myotubes with EDA2R ligand, that is the ectodysplasin A2 receptor ligand, triggered pronounced cellular atrophy by induction of the expression of muscle atrophy related genes atrogen1 and MRF1. The ectodysplasin A2 driven myotube atrophy involved activation of the non-canonical NF-kappa beta pathway and was dependent on the NF-kappa beta inducing kinase activity. They found that the EDA2 receptor, EDA2 overexpression, that is the ectodysplasin A2 overexpression, promoted muscle wasting in mice, and deletion of either EDA2R or muscle NF-kappa beta inducing kinase protected tumor-bearing mice from loss of muscle mass and function. In addition, they reported that tumor-induced oncostatin M, OSM, upregulated muscle EDA2R expression, that is the ectodysplasin A2 receptor expression, and muscle-specific oncostatin M receptor knockout mice were resistant to tumor-induced muscle wasting. These investigators said that their results demonstrate that EDA2R and NIK signaling mediates cancer-associated muscle atrophy in an oncostatin M receptor-dependent manner. They argued that therapeutic targeting of these pathways may be beneficial in the prevention of muscle mass. Given the findings of the JACC paper, it would be interesting to go back and look at these knockout mice and patients and determine whether the skeletal muscle atrophy was associated with atrophy of the cardiac myocytes. So this would be a very interesting study to do with this mouse model. The pathway for muscle mass: 1. The oncostatin M receptor, or combines with the oncostatin M activating gene for receptor EDA2R and promotes muscle breakdown. Secondly, the receptor protein EDA2R is strongly expressed in muscle biopsies obtained from animal models and humans with cachexia. And finally, interaction of the EDA2 protein with the EDA2 receptor stabilizes the NF-kappa beta inducing kinase enzyme, which enables activation of the pathway mediated by NF-kappa B. This in turn increases expression of the genes atrogen1 and MRF1, which mediates muscle breakdown. So this is an exciting paper regarding cachexia, regarding skeletal muscle cachexia. It would be interesting to extend this to the cardiac muscle. The third paper being discussed is from Nature, which is kind of the inverse of cachexia. It was in obese mice, and it found that the growth differentiating factor 15 promotes weight loss by enhancing energy expenditure in muscle. The investigators treated rodents with a high-fat diet and recombinant growth differentiating factor 15 and found it reduces obesity, improves glycemic control through the glial cell derived neurotrophic factor family receptor alpha or GFRAL dependent suppression of food intake. These investigators, in addition, found that in addition to suppressing appetite, the growth differentiation factor 15 counteracts compensatory reductions in energy expenditure, eliciting greater weight loss and reductions, particularly in non-alcoholic fatty liver disease. This effect of the growth differentiation factor 15 to maintain energy expenditure during calorie restriction requires a GFRAL beta adrenergic dependent signaling axis that increases fatty acid oxidation and calcium futile cycling in the skeletal muscle of mice. These investigators argued that the therapeutic targeting of the GDF15 GFRAL pathway may be useful in maintaining energy expenditure in skeletal muscle during caloric restriction. It would be interesting to investigate this pathway in people with cachexia and see whether the reverse is true. So once again, these are fascinating studies looking at cachexia. A lot of research has been done at the cellular level in heart failure, where the heart is significantly heavier, but less so in patients with cachexia. These findings suggest that cardiac wasting is more common in cancer patients than known in the past. It would be important to confirm this with using cardiac MRI, and more importantly, to look at mechanisms using possible pathways discussed in the Nature papers.